Okay, so let's start. Go on to section 3. I'm going to go ahead and just tell you what I wrote them on your PowerPoint, so you have a list there of the ones that you need to know. And a lot of these are associated with the bones as well, so you'll already be familiar with several. So first one here is the zygomaticus. Okay, sounds like the cheek. Zygomaticus. That's the cheekbone. So that's the muscle that goes across the cheek. Okay. The sternocleidomastoid. This one is kind of at the back of your neck and wraps around a little bit. Sternocleidomastoid. The names will tell you a lot about where they are, right? So sternocleidomastoid, what do you hear?
Sternum.
Sternum. Okay, so it attaches up the sternum in the front. And then it originates where?
Mastoid.
The mastoid. Where's your mastoid process?
Right.
Right under here. So that's where it goes. Travels. That's the direction it goes. Masseter. This is right here. This is like the cheating muscle. Okay. Go inside your cheek there. Orbicularis oculi. Oculi tells you it's related to what?
Eye.
The eye, like ocular. So orbicularis, orbit, okay, tells you that it has a circular nature. So orbicularis oculi is this circular muscle around the eye. Okay, and then orbicularis oris, then oris is what's the root word there? And these pictures, I know they're tiny on here. They're in your textbook too. So these are the pictures from your textbook. So you can, that's why I wrote them out to the side because you can't, they're so tiny on there. You can't see them. Okay, oris, like oral, okay, mouth. So orbicularis oris is the circular muscle around the mouth. And that's all on that picture. All right, trunk muscles. Here, I want you guys to know, first one is the external obliques. Okay, and one thing that you'll notice with the internal and external, obviously one's more superficial than the other, but the other thing is that they go different directions. So the external oblique kind of goes down towards the front, okay, and the internal oblique is like an angle more, an upward angle. If you're coming from the outside, I guess. Okay, so that's external and internal obliques. Rectus abdominis, those are your abs. Maybe you can say your abs. That's the straight. Rectus means straight, so that's this long muscle right along the middle of the belly. And that's what that separation, that's intended sheets in here, is what gives people like the ab look, right? The six-pack look or whatever. It's those sheets in there that give it that. Okay. The trapezius, you probably heard of traps before, that term. Okay, it's got a large triangular shaped muscle in the back. You can really feel that's a big muscle right here, kind of in the middle of your back of your shoulder. Okay. That's the trapezius. And then the latissimus dorsi is not written on here, but it's this muscle right here. Right here, right now. It goes, kind of starts at the bottom, lower portion of the back and goes upward. Latissimus dorsi.
Oh, you got it in here.
This one right here.
Get it right in there.
I know, but it's not, there's nothing pointing to it, so.
Dorsi like dorsal.
Mm-hmm. So a lot of people get trapezius and latissimus dorsi mixed up, so make sure you study those together so you know which one is which, okay? Traps are kind of up here behind your shoulders. You see that a lot on bodybuilders and stuff when they they do their shrugs and they do what's the word?
Flex.
Flex, thank you. It sticks way up on the shoulders. All right, upper limbs, so your arms, some of these you'll know. Okay, your deltoid is kind of right on the edge of the shoulder. That's where you get a shot. It's in the deltoid. Why do you think it's called the deltoid? Oid at the end of a term means what?
Void.
It means resembles. Like the thyroid resembles a shield. Deltoid, what's a delta?
A triangle.
Triangle. So it looks like triangle. Okay. Well, what happened to my cart? The
You're right.
plastic cart that my little man back there goes on. Do y'all know?
I don't even know what you're talking about.
Little car that was back
You
there.
know, this guy went on. It was like a rolly cart, had my goggles on it.
Oh,
Oh, yeah, all my goggles.
mm-hmm.
But somebody bought it.
People borrow carts and get them back. Anyway. Okay, pectoralis major. That's the chest muscle. You know what your pecs are. Okay, pectoralis major. There's also a minor. Oh, look, there's the one. It's considered a trunk muscle, I guess. So, I mean, they're considering an upper limb muscle instead of a trunk muscle. That's good arm movement. Biceps, brachii, and triceps. Of course, your biceps are on the front, and triceps are kind of on the posterior part of your arm. And then the lower limb muscles. Okay, first one is the sartorius. It's a long, kind of slender muscle. Starts at the hip and go down to the inner part of the knee. Another one you need to know, vastus lateralis. That should be this front muscle. That's okay, it's on the outside. Vastus lateralis, that means the side. Kind of the outer thigh. It's the outer part of the quad. And the quad is made up of 4 different muscles. And that is, so vastus lateralis. I always remember this one because that's the one that for babies, you can't give them a shot in their hip because they don't have enough muscle yet in their bottoms to give them a shot there. And started walking that. So vastus lateralis is usually the largest muscle for babies where you give an injection. Okay, tibialis anterior. Okay, you think it'd be close to the what?
Tibia.
Tibia, and what side of the body is it going to be on? Anterior, which is the
outside.
that's lateral.
Oh, inside now.
Anterior is front.
Oh.
Medial's inside, lateral's outside, anterior's front, posterior's back. So tibialis anterior is that muscle. You kind of feel it on the right on the outside of your shin bone, your tibia. Okay, that's your tibialis anterior. Gluteus medius. Okay, that's the smaller muscle up here on the hip. Gluteus maximus is a larger muscle that makes up your buttocks. Medius is really where you give an injection. And then gastrocnemius is the last one, and that is your calf muscle. Gastrocnemius. I don't know why it's called that, gastrostomach, but yes. Okay, so those are the muscles you need to know for the muscle quiz. That will be next, what did I put, Tuesday?
Mm-hmm.
Okay, so that'll be Tuesday. All right, other than that, let's get started on the lecture.
You should keep your laptop plugged in all the time.
It was dead this morning. I guess I didn't turn it off whenever
I'm like the new one. Mine is, I've had it since 2008, and you get the batteries messed up in here. I mean, if you unplug it, it's going to go dead, like just instantly. You have to keep plugging it constantly. It's a pain trying to carry the cord around and everything with it.
I thought mine was all charged. And then I guess I shut it. I guess I closed it now and it shut down. So stay on. All right, y'all turn in your books to 157. All right, muscle tissue. We've already talked about some of this. So we know that there's 3 types of muscle tissue: skeletal, smooth, and cardiac, right? So this chapter really focuses on the skeletal tissue. We'll get to cardiac when we get to the heart. We'll look at it a little bit more. And then smooth muscle, we've pretty much already, there's not whole lot to know about smooth muscle. Okay, but which one of these is, or which one of these are involuntary?
Cardiac.
Cardiac. For your diaphragm being involuntary. I mean, because you can move it, but it also you breathe without not meaning to.
I think diaphragm.
And then you got the hiccups and you can't control them.
And smooth.
I'm not sure diaphragm. I'm not sure if it's considered skeletal or smooth. But smooth is the other one that's involuntary. I would think that the diaphragm would be skeletal, but it just happens to be involuntary. Yeah. But, yes, so those are your 3 types of tissue. We know that skeletal muscle tissue, when you look at it under the microscope, which you guys are going to do next week to identify which one is which, what are some things you're looking for to identify skeletal muscle tissue?
Maybe.
How do you know? How do you know if it's skeletal versus cardiac versus smooth when you look at it under a microscope?
I can't remember. Like one of them is like real fibery, and your skeletal muscles got the fibers in it, and then your heart is real connective, like.
Mm-hmm. Okay, look at 157. You're right. You're on the right. I think you're talking about striations is what you're talking about instead of fibers.
Yeah.
Okay, so skeletal muscle tissue and cardiac muscle tissue both have striations, little lines, and you can see them pretty good usually on the microscope. Now, my skeletal muscle tissue slide is not that great, but you can really see it. Another thing to know is look at the nuclei in these. What do you see as a difference between skeletal and cardiac when you're looking at the nuclei? What's the difference when you're looking at the
On the cardiac, it has
versus skeletal?
like something surrounding it.
Okay. What else?
Cardiac's all connected, while the other ones are they're connected, but they're not single strands, kind of.
Okay. So one thing to know, skeletal muscle tissue can be multinucleate. That means one muscle fiber or one muscle cell can have many nuclei because they're really long. You think about one muscle fiber can be as long as an entire muscle. If you think about the sartorius, it goes from the hip to the knee. That's one very long cell. Okay? So it can have multiple nuclei versus cardiac. See how they're like interconnected kind of and they cross over onto each other? Each one of those each cell is separated from another cell by those intercalated discs. Remember I was talking about those? Those are pretty obvious to see on the microscope. So that's one thing to look for. Now the other thing is that each cell only has one nucleus. Those intercalated discs are really important because they have gap junctions in them, which allows for transport to easily move, especially we're talking about an electrical impulse because those need to be able to transmit an electrical signal, and that's important in the heart. Okay, smooth muscle tissue, if you'll notice, it doesn't have striations. Remember on the microscope, they kind of just look like little hairs or something. They were very smooth, one nucleus per cell, and they don't have all of those striations. Okay. All right, so a couple things. One, whenever you read in here, or you hear me say a muscle fiber, that's the same thing as saying a muscle cell. It's just one cell, one fiber is one cell. Okay. Now, the muscle also has different names for other cell parts. So the cell membrane or the plasma membrane, like we talked about, in muscle cells is specifically called the sarcolemma. SARCOLEMMA. It's at the bottom of page 156. Okay. So let's look at, kind of got ahead of us, kind of got crazy on here. Okay, functions. So a few things to look at. Behavioral properties. One thing, what are some things that muscles do?
What do you mean?
What do muscles do? What makes those cells special, different from other epithelial cells or connective or something else?
They control our skeleton, control how we move.
Okay. So how do they control movement? What do they do?
Contract.
Okay, good. So contractility, there's 4 major behavioral properties. One is contractility, right? So they have the ability to contract. Now, one thing to note is that muscles don't push, they really only pull. So, for example, if I move my arm up, okay, we know that your bicep is what contracts, right, to move that up. Okay, your tricep doesn't do anything when you're moving your arm up, except provides a little bit of tension, if you will, so it doesn't just, it's got tension there, but it doesn't push your arm up. Muscles don't push, they always work in pairs. So your bicep pulls this direction, your tricep is what goes into action when you do that, when you go the other way.
So when you push out your tricep, right?
Probably a little bit of both. It depends on your movement and what you're doing. And the type of movement. We'll talk about different types of exercise.
So if you're working on your arms really wide, it uses more of your chest muscles, and if you're inside, it uses more of these.
It probably needs to. But yeah. But muscles only do one action. They don't do both. Like my biceps don't move my arm, don't flex and extend my arm. Does that make sense? They only do one of those. And the tricep, they work together to do that. Okay, one other thing, or another behavioral property is their irritability, right? They can actually receive messages, and that's what tells it to contract. So each muscle fiber is attached to the nervous system by a neuron, and each one has its own and tells it to contract. And it's able to respond to that. That's what gives it its irritability. Okay, extensibility. Has an ability to be stretched, right? Muscles can be pulled or stretched. Not all tissue can do that. And then elasticity is its ability to go back to normal when it's been stretched. Now, sometimes, obviously, if you tear it or you injure it, then those don't always happen. Okay, one other thing to note is the tensile force or tension. And I still got ahead of myself. Let me just say that. Yeah, this pulling force. So, like I just said, your triceps have that pulling force while your biceps are actually contracting. They work together. Oh, what are you doing? Are you looking up anatomy stuff on there?
Okay.
Put it up. No, put it up. Put it up. I'm being very rude right now. The amount of tension developed is constant throughout the muscle, tendons, and attachment sites. So tensile force is just the ability of your muscles to have kind of a constant state of force or a tone. That's really called the tone. So it's got, just like I said, you pull your bicep up, right? Your bicep pulls your arm up, flexes your arm. The tricep doesn't just like let it free fall. It still has some tension in it to keep it from injury. Okay, look at, kind of all over the place today and within the book anyway. There's three ways tension can build up in muscle. Okay, first one is that the muscle shortens and it contracts. That's tension built up in the muscle, right? Energy that's waiting to be released, if you can think of it that way. So look at the top of 160. You got 3 different types. Okay, it says concentric contraction. The agonist bicep contracts, and the antagonist, that'd be the tricep in this case, would relax. Okay, so look at this eccentric contraction. As the bicep is eccentrically contracting or lengthening while serving as a brake. So what it's talking about is if I'm holding something, okay, my tricep isn't the only one working here. My bicep is providing that force to keep it from just dropping. Okay, it still has that pulling force. And then isometric is actually where it doesn't move. That's isometric. Iso, remember, means same. So they're both working together, but it's staying in one spot.
Kind of pulling against each other.
Right. It's kind of like it's kind of like a kind of like balance, between all of those. So basically the muscle shortens, that's concentric. The muscle lengthens while it's still contracting, that's eccentric. And then if it remains the same in one spot, that's isometric. Like isometric movement or exercise even would be where you're not actually doing any movement. So if I'm lifting something and I get it to here and I can't lift it anymore and it's just stuck, that would be isometric, can't do anything else. It wouldn't take much more for me to get to this spot in the stapler, but anyway. So muscles always work in pairs, like we said. All right, we already talked about this. Okay, skeletal muscle organization. I'm kind of going backwards again. All right, so you've got some different things. Like I said, the sarcolemma is the same thing as the plasma membrane. It just has a different name. Everything's got a different name in the muscle. I don't know why, but it does. Okay, the endomysium. Okay, endo tells you it's what?
Inside.
Inside. Okay, this actually covers right on the outside of each cell. Okay, so it covers the sarcolemma. Endomysium is just like this muscle covering, okay, that protects it and does that. Now the perimysium, okay, peri means around, right? So it'll be easier if you'll memorize these kind of in order. Endo, peri, epi, goes in that order. These bundle up groups of muscle fibers to make what's called a fascicle. If you'll turn over, look at page 158 and you can see this. It's really clear, this picture, if you want this one. Okay, so you have your individual muscle fiber, and again, this is all skeletal muscle, okay, and it's covered by the what?
The endomysium.
The endomysium, right? The sarcolemma, the plasma membrane is covered by the endomysium, and then these are all, you have bundles of muscle fibers called a fascicle, okay, and that whole fascicle then is wrapped by the perimysium. And then the whole muscle itself, like if you're talking about your bicep, okay, your whole bicep is just made of chunks of fascicles, okay, all bound together by what's called the epimysium. Remember, epi, it just means superficial or on top of or above, like your epidermis. Okay, so
where's your sacrum?
Sarcolemma.
Oh, I say it.
Sarcolemma.
Sarcolemma, yeah.
that is the same as the plasma membrane. So it surrounds each cell.
Okay.
But that's just like the wall of the cell. You know what I'm saying? That's like just like the plasma, like when we were doing those eggs, we looked at the plasma membrane. Plasma membrane in muscle cells is just called the sarcolemma. I don't know why they renamed it, but they did. But that's the structure. Okay? So that's the structure of a muscle. It just kind of gets smaller and smaller and smaller until you get to those individual cells. And then it says an aponeurosis actually connects muscle to other tissues. So your aponeurosis is just that connection of whatever the muscle is connected to, whether it's cartilage or bone or whatever. Okay. So I just memorize them in order. Endo, peri, epi. We're starting from the inside going out. Okay, smooth muscle is voluntary. True or false?
False.
Good, false. Cardiac muscle has branching fibers.
True.
Yes. Smooth muscle is multinucleate. Which one's multinucleate?
The muscle.
Skeletal.
Skeletal. Good. Perimysium wraps fascicles to make a muscle. Yes. Endomysium surrounds the individual muscle fibers. Oh yes, you're right. The red one is epimysium. Okay.
I did too. I was like, no. It's the bundle.
Okay, we just talked about these. Okay. I got excited. I way ahead of myself there. So the four behavioral properties, like we just talked about, extensibility is just its ability to be able to be stretched and move back to normal spot. or elasticity is its ability to be moved back. Irritability is its ability, it's hard to say altogether, to respond to nervous impulses so that they can contract, and then, of course, their ability to contract is shortened. I got like, they must be out of order or something. I don't know. I got excited. That's okay. All right. So, ability to respond is its what?
Irritability.
Irritability. We're going to talk about that word quite a bit whenever we get to the nervous system too. Okay. Opposes movement. Which one does that? Looking at agonist versus antagonist. Think about your story, like you're reading a story in English.
Antagonist.
Antagonist is usually the what?
The bad person.
The bad guy, right? So same idea. So they're opposing the movement of the agonist. So it's kind of like positive and negative. Stretch. Extensibility. Shorten is its contractility, and then I would say causes movement is also contractility.
Wouldn't it be agonist?
Oh, yes, thank you. Was there an extra word?
Yeah, elasticity.
Okay. All right, so the skeletal muscle. Is the motor unit. The motor unit is kind of like the functioning portion of the muscle chapter. So the motor unit is a group of muscle fibers that's under the control of one motor neuron. So we know what does the word motor mean?
Like to make work.
Work or move. Okay, whenever you're looking at it as far as healthcare is concerned, anytime they say motor, we're talking about ability to move, like they have decreased motor function, means they're not able to move like they're supposed to. Okay, so they movement. So one motor neuron, okay, remember a neuron is just a nervous tissue cell that carries an impulse. One neuron can be connected to multiple muscles. Okay, so you can kind of see here, so you've got this motor unit A, for example, has 3 muscle fibers in here. And this one's got other ones. And some of them are even connected to the same one. So it's kind of like it's got fingers that are attached to specific fibers. So every fiber has a neuron attached to it. That's how it gets its message to contract. Well, one neuron plus all of the muscle fibers that it's connected to equals one motor unit. And that's really kind of the functional part of the muscle. It says one motor neuron supplying impulses to a muscle may connect to anywhere between 100 to almost 2,000 skeletal muscle fibers. So one neuron can have that many axons that head to those muscle fibers. Pretty crazy. Depending on the size and function of the muscle. It says the small muscles responsible for finely tuned movements, such as those in the eyes and fingers, have small motor units with few fibers per unit. And large, powerful muscles, such as those surrounding the hips, have large motor units with many fibers. Does that make sense? Okay. All right, action potentials. You're going to hear that word a lot when we get back from the break too. An action potential is just a nervous impulse. That's all it is. It's a nervous impulse that travels along a neuron. All right. Okay, acetylcholine, we're going to talk about this later on too. But you jump ahead sometimes in this book. Acetylcholine is a neurotransmitter. Okay? And I'll kind of explain how neurons work. I don't think we necessarily talked about that. Okay, neurons. Everybody remember kind of looking at neurons and how they were shaped? Whenever we were looking at them under the microscope and stuff. Okay. All right. Well, where a neuron touches whatever whatever it's trying to send a message to. Okay? Let's say this is the muscle fiber. There's actually a little gap in there. They don't touch. They don't ever actually meet. They just get close enough and they stay close enough that they send chemicals across the way. And that's what actually carries the message. Those chemicals that it sends, whatever it's going to, whatever muscle it's going to, or whatever organ, whatever, those are called neurotransmitters. Think about transmits a neuro message. Okay? And for muscles, in particular skeletal muscles, acetylcholine is the name of the neurotransmitter. Well, there's a lot more to it than just that, but that's what it's talking about. It says acetylcholine, specifically talking about that neurotransmitter. And there's medications. The reason that this is so important to know is, one, that can cause issues and other things. So sometimes if somebody's having pain, it can be a neurotransmitter issue. Or a lot of medications that they use, that's where they affect the neurotransmitters and make them not work or work the way they're supposed to. That's one thing to know. Interesting.
You ever see like those documentaries or whatever, if you're learning about it, you see like that shape you drew when two of them were close to each other? Where's that at? Like,
well, you can have two neurons close to each other that are passing messages back and forth. But a lot of times you'll see like pain receptors, for example. A lot of times pain medicines work in that area where they try to get rid of some of those that neurotransmitter, to make it so it won't pass the message along. I feel like you see that a lot, especially like depression, maybe depression medications and things like that. Yeah, you'll see that. It's just a different neurotransmitter. Like SSRIs are a type of antidepressant. Selective serotonin reuptake inhibitors, what that stands for. And so it does what it sounds like. Serotonin is the name of that neurotransmitter, and it inhibits the reuptake of it. So it makes it keep going, keep putting out serotonin. So, yeah, that's a really important thing just to know, kind of how it works. Anyway. The synaptic cleft or the gap, sometimes you'll hear it called gap or cleft. That's the name of that little space in between, if you read that in here. All right, so the neuromuscular junction, I don't know where's my picture, but that's where that neuron attaches to that muscle fiber. And then the little bitty gap in between is called the synaptic cleft or synaptic gap. Because right where those meet, anytime a neuron meets something, that's called the synapse. So that gap is called the synaptic gap or the synaptic cleft. That's where we'll hear that word a lot more. But I get it in here. All right. It says the effect of acetylcholine is to make the sarcolemma temporarily permeable. So listen to this, methadone 163 on the left-hand side. Channels open, so when it changes the sarcolemma and makes it permeable to other things. Look at this. Channels open in the sarcolemma, that's the plasma membrane, that allow positive ions, so sodium, to invade the fiber, okay? At the same time, that potassium rushes out. And we're talking about sodium-potassium pumps earlier this year. Because more sodium enters than potassium exits, the net effect is the creation of a positive charge inside the fiber. So it changes the permeability of that muscle fiber, and it makes it so that a whole bunch of sodium rushes in. Because it's rushing in so much faster than the potassium can leave, it changes the charge of that muscle fiber. Well, that's what that is the electrical impulse, the changing of a positive or negative charge of a cell. That's what causes that nerve impulse to travel. That's how your neurons work. That's why it's so important. We talked about electrolytes and your sodium and potassium balance, and that's why those things are so important to have them where they need to be, because they can affect how your muscles work, how your heart works, all of that. So that's called an action potential, or depolarization is that flipping of that it's kind of like a zipper, and it just like flips it all the way down. It's pretty, I don't know, pretty crazy. Start thinking about how it works. All right. Okay, so look at the bottom of 163. It says glucose stored in the form of glycogen, talked about that before, within the muscle cell provides the energy for creating the action potential. Okay, phosphocreatine within the cell enables the transfer of energy to the protein filaments, actin and myosin. Actin and myosin are contractile proteins inside these. This is within the cell. Okay, you actually have tiny. Oh, look, there was a picture on the next page of that. You have to draw it. Anyway, sarcomeres are the contractile unit within the muscle fiber. So we're talking, these are tinier than the cells, than the cell itself. These are inside the cell. And these are actually individual contractile units. So look at this on 164. You can kind of see the pictures there of the sarcomeres. This is what gives skeletal muscle its striated look. So if you look at that, see how, look at the pictures. Oh, yeah. Okay, so see how you have, okay, you have the myosin, and you have the actin. Okay, this little gap, this is what, these gaps just keep going. The next one, this is what gives skeletal muscle its striation look from far away. But if you look at it in the microscope, it's these little lines inside of here. Those are the little light colored lines of striation. Okay, so when it receives that action potential, it's telling it to contract. The sarcomeres, the whole unit, this myosin actually, these little heads on it, reach up, grab onto the actin and pull. They kind of work like little arms. And they pull, and when they do that, they pull it close. Okay. So there it's relaxed, here it's contracted. Isn't that crazy? Every single muscle fiber has sarcomeres in it, and that's just how it functions. It's crazy. I can't believe that picture was there and I didn't notice it. Says what causes the actin filaments to slide over the myosin filaments. I'm reading by that part. Says these heads attach to receptor sites on the actin filaments. The actin are the little purple ones on there, forming cross bridges, and these cross bridges contract and pull the actin filaments toward the center of the sarcomere. It says calcium ions released when the action potential is what enables them to do that. The neuromuscular system has the ability to produce slow, gentle movements as well as fast, forceful ones. The ability to produce different kinds is accomplished by regulating the number and frequency of action potentials. So if it needs to contract really, really hard, it's going to keep sending action potentials, and one right after the other. So your brain kind of measures out how much you need, and it does that too just by going. All right. I think we'll stop there. I think the bell's going to ring in just a second. I will get the rest of this done. I think I have a video probably that's already, I think I did last year. I won't be here, by the way, Thursday. So Miss Trapp will be here subbing for me.